Your FastMCP server is wasting cycles recalculating the same tool results, listing identical resources, and fetching unchanged prompts over and over again. We'll configure targeted response caching that lets you set different TTLs for tool calls, disable caching for specific operations entirely, and even restrict caching to only certain tools, all while keeping your core logic untouched.
From FastMCP server middleware caching, import response caching middleware. Call tools settings, list tools settings, read resource settings. MCP, add middleware, response caching middleware. List tools settings equals list tools settings. TTL equals 30. Call tool settings equals call tool settings. Included tools equals tool 1. Read resource settings equals read resource settings. Enabled equals false.
This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. The code configures a caching layer that intercepts specific operations, tool calls, resource reads, and listings before they reach your business logic. Unlike traditional decorators that couple behavior to individual functions, middleware operates at the protocol level, applying consistent policies across all operations. The pattern works by creating a chain of responsibility where each middleware can inspect, modify, or short-circuit requests and responses. Here, the caching middleware uses time-to-live settings to store frequent operation results, with granular control over which operations get cached and for how long. The declarative configuration separates caching policy from implementation, letting you adjust behavior without modifying core logic. This approach solves the problem of redundant computations and inconsistent caching policies in distributed systems. By centralizing caching at the protocol layer, you ensure all clients benefit from the same performance optimizations without requiring per-tool implementation. The trade-off is increased memory usage for cached items, which is why the configuration allows disabling caching for specific operations like resource reads. Let's break it down line by line.
From FastMCP server middleware caching, import response caching middleware. Call tools settings, list tools settings, read resource settings.
Imports the caching middleware and its configuration classes. Response caching middleware handles caching for different MCP operations, while the settings classes define cache behavior per operation type. This modular design lets you configure caching granularly for list, call, and read operations.
MCP, add middleware, response caching middleware.
This registers response caching middleware in the FastMCP middleware pipeline, intercepting and caching responses before they reach the client. Middleware pattern lets you modify requests responses globally without changing individual tool implementations. Here it optimizes performance by reducing redundant computations.
List tools settings equals list tools settings.
This configures caching behavior for the list tools endpoint. The list tools settings class defines TTL and other caching policies specifically for tool discovery operations, optimizing repeated requests for available tools.
TTL equals 30.
This sets a 30-second time to live for cached list tools responses. It balances performance and freshness, preventing stale tool listings while avoiding excessive server load. Standard TTL pattern for caching middleware. This closing parenthesis terminates the read resource settings configuration block. It finalizes the middleware setup, allowing the response caching middleware to be properly instantiated with all specified caching rules. Without this, Python would expect additional arguments, causing a syntax error.
Call tool settings equals call tool settings.
This configures caching behavior specifically for tool execution calls. The CallToolSettings class lets you define which tools get cached and for how long, optimizing performance for frequently used operations. In this case, it's only applying caching to Tool 1 while excluding others.
Included tools equals Tool 1.
This restricts caching to only the specified tool, Tool 1. By explicitly including tools, you prevent unintended caching of other tools, ensuring precise control over which responses get cached. This is critical when some tools return sensitive or volatile data that shouldn't be cached. This closing parenthesis terminates the Read Resource Settings configuration block. It finalizes the nested settings structure for the caching middleware, ensuring all parameters are properly contained before the outer middleware initialization completes.
Read Resource Settings equals Read Resource Settings.
This configures caching behavior for read resource operations. The Read Resource Settings class lets you disable caching or set TTL for resource reads, preventing stale data or unnecessary cache hits. Here, we're passing an instance to customize this specific operation type.
Enabled equals false.
This explicitly disables caching for read resource operations. Without this, FastMCP would cache responses by default, which could lead to stale data being returned for resource reads. The pattern mirrors how other settings are configured in this middleware block. This closing parenthesis terminates the response caching middleware configuration block. It finalizes the middleware setup with all specified caching rules for list tools, call tool, and read resource operations. Without this, the configuration would remain incomplete and raise a syntax error. Closes the middleware configuration block. This final parenthesis completes the response caching middleware instantiation, allowing FastMCP to register and apply the caching rules we just defined. FastMCP caching pattern. The response caching middleware demonstrates FastMCP's declarative approach to performance optimization, where caching behavior is configured through settings, objects rather than imperative code. Cache keys for list operations are global by default, which can cause collisions when sharing storage across multiple servers. Granular control over TTL and included tools prevents stale data while maximizing hit rates.
The cache that remembers everything forgets its own boundaries.